Hello everyone. So today we're going to be solving the infinite square world problem, problem 2.5 from Griffiths. And what they do is they give us the time-independent wave function at a specific time, at time equals 0, and it's a function of the first state and the second state with a normalizing factor. The first question asks us to find A. So essentially normalize, and how we do that is we integrate from minus infinity to infinity of psi star and psi. So it would be psi star and psi dx, which is just equal to those terms with their conjugates. So what we get is A psi 1 of x plus psi 2 of x, A psi 1 star of x plus psi 2 star of x. Now we just extend this out and collect the terms. So what we're going to find is that these terms are equal to a squared times psi 1 of x times psi 1 star of x plus the last term, which is psi 2 of x, psi 2 star of x. And now we're going to get the cross terms. So now what we're going to do is we're going to use the orthonormality to make sure that these terms go to 0. So this is from equation 2.33 in your book. And we can just get rid of these terms. And then we collect these two terms using equation 1.20 to write them out as the conjugate norms. Now, what we do is we set this entire thing equal to 1, and then we can solve for a because we have all the other terms. So 1 is equal to a squared psi 1 squared plus psi 2 squared. I've been forgetting my integral signs. Integrate minus infinity to infinity dx. Now what we do here is we split each integral into its independent terms. So what we find is we have a squared times the integral of psi 1 of x plus a squared times the integral a squared times the integral of psi 2 of x from minus infinity to infinity. And we know that each of these individual terms are just equal to 1, so that's equal to 2a squared. This just goes to 1, this just goes to 1, 2a squared. And we've set that equal to 1, so we get 1 over 2 is equal to a squared, and therefore a is equal to 1 over the square root of 2. So this will give us our normalized version of psi, which we can write as 1 over the square root of 2 times the linear combination of the first and second states.